In this lesson, we're going to talk about the difference between dependent and independent events and how they pertain to statistics and probability. Two events are independent events if the occurrence of one event does not affect the likelihood that the other event will occur. And on the opposite side of that, two events are dependent events if the occurrence of one event does affect the likelihood that the other event will occur. So, let's talk about these two scenarios and talk about what makes them either independent or dependent. Let's say you flip heads on one coin, and then you flip another coin, and it turns out to be tails. Does what you did on the first flip of the first coin impact what happens on the second coin? It doesn't. Therefore, because the first event did not impact or change the possible outcomes of the second event, these are independent events. The first event did not affect the second event. Two separate coins, two separate outcomes. One does not impact or affect the other. How about example B? Your teacher chooses one student to lead a group and then chooses another student to lead a second group. So the first event, the teacher chooses one student from the entire class. That student becomes the leader of a group. And then the second event is her choosing the leader of another group. What changes is the total number of students that your teacher has to choose from. Because after the first student has been selected, that student is no longer part of the whole class to be chosen from. So if there are 20 students total in your class, the first student was chosen to be the leader of a group. Now there are 19 students left to be chosen from for the second group. Because the first event impacts the probability of the second event, that makes these dependent events. Okay? And that's E-N-T, not A-N-T. So first we're going to talk about calculating the probability of independent events, meaning that the first event does not impact the second. So if we wanted to know the probability of two independent events both occurring, probability of the independent events A and B, it is the probability of A times the probability of B. This is the formula that you will use. The probability of A and B is the probability of A times the probability of B, meaning the probability that both events occur is the probability of the first event times the probability of the second event. So these are going to be independent events. Flipping two quarters. We already said that flipping one coin does not impact the flipping of the second coin, so they are in fact independent. You flip two quarters. What is the probability that you will flip two heads? Well, here's the first flip. You can either get heads or tails. And then the second flip, you can either get heads or tails. So if we look down here, you could flip, you could get heads first and then heads second. You could get heads first and then tails with the second coin. You could get tails first, then heads, or tails first and then tails second. So our outcomes are heads, 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 tails, tails, heads, dropping stuff, tails, heads, or tails, tails. We have four possible outcomes. How many of these outcomes are both heads? 1 out of 4. Okay? So we could use this method, but frequently it gets kind of messy, but it works. So we go back to our formula where we say the probability of both events occurring is the probability of the first times the probability of the second. And we know that flipping a coin, the probability of getting heads is 1 to 2, because our favorable outcome is heads. There's one option. Out of two options, heads and tails. So the probability of heads and heads is going to equal the probability of the first event, which is heads, times the probability of the second event, which is, we want to find the probability of heads. So the probability, I'm having a hard time with these markers, the probability of flipping heads with the first coin is 1/2, so it's 1 to 2. And we're going to multiply that by the probability of getting heads on the second coin. One does not impact the other, they're independent. So when we multiply 1/2 times 1/2, we inevitably come up with 1/4, which is what we got when we mapped it out on this tree diagram. So both are possible ways of figuring it out. We will practice both ways. The next thing is finding probability of dependent events. Remember, the second event is impacted by what took place in the first. So the probability of two dependent events, A and B, is the probability of A times the probability of B after A occurs. So here, the probability of A and B equals the probability of A times the probability of B after A. Okay? So again, the probability of both events, probability of the first event equals the probability of the second event after the first event occurs. The next example will make this make a little bit more sense, I think. So, the following flowers are in a vase. You have 7 purple flowers, 9 yellow flowers, 12 pink flowers. That's 28 total flowers in a vase. You randomly choose a flower from the vase. Later, your friend randomly chooses a flower. What is the probability that you choose a purple flower and your friend chooses a yellow flower? Now, you're going to choose a flower first, just like your teacher chose a student first. There are 7 total purple flowers out of 28 total flowers. So 7 purple out of 28 total. That simplifies to 1/4. 1/4 is the probability of the first event occurring because there are 7 flowers that are purple that you could possibly choose out of 28. But then the probability that your friend chooses a yellow flower changes. It's not out of 28 because you took one of the flowers, so now there are only 27 left. That's what makes this dependent and not independent. Well, there are 9 yellow flowers, but there are 27 remaining, 27 total. 9 out of 27 is going to simplify to 1/3. This 1/3 is the probability of B occurring after A has already occurred. I took my flower, and then you take yours. That's the chance. So we come back to our formula. The probability of both of these things occurring is the probability of the first times the probability of the second. So the probability that we have purple first and yellow is taken second is going to be 1/4 times 1/3, which will be 1/12. And this 1/12 is approximately 8-ish%. So there's an 8-ish% chance, a 1/12 chance that this event will occur. Purple first, yellow second, if it's done randomly. Lastly, we're going to work with some independent events to calculate their probabilities. You spin the spinner, then flip a coin. Spin the spinner, then flip a coin. This spinner here. Find the probabilities of the given events. So spinning a 4 and then flipping heads. Keep in mind these, again, are independent events. What I spin on the spinner does not impact how I flip the coin. So spinning a 4, so what the probability of spinning a 4 is going to be 1 out of 10, and we multiply that by the probability of flipping heads, which we know is 1/2. So the probability of both of these events occurring is going to be 1/20, because it's probability of A times the probability of B. Spinning an even number and then flipping tails. Well, there are 1, 2, 3, 4, 5 even numbers, 5 out of 10, so the probability of spinning an even is 5 out of 10, or 1/2, and then flipping tails, the probability is 1/2. So the probability of both of these occurring is 1/4. So it's unlikely, right? 25%. Spinning a multiple of 3 and flipping heads. Well, there's 1, 2, 3 out of 10 multiples of 3. And flipping heads is going to be 1/2. So 3/20 is the probability of getting a multiple of 3 and also flipping heads. And then lastly, spinning white and not flipping tails. Well, half of these sectors are white, so that's 1/2. And not flipping tails, well, if you don't flip tails, you do flip heads, which is still 1/2. And both of these events occurring as we multiply, their probability is going to be 1